Let us solve this question next. What does the question say? We have sine square 6x minus sine square 4x, which is equal to this. How do we approach this question? How do we approach this question? We have a few methods which we can use. One of the results, if you remember one particular result, okay, this is not given in the NCERT, but if you remember that result, this question becomes direct. What is the result? Result is sine square A minus sine square B. This is equal to sine A plus B times sine A minus B. Now, since I am giving you a new result, yeah. If you have studied only from the NCERT, you would not encounter this result. But then, if you know this result, you can solve this question directly. Okay. Okay. So, is this some kind of a trick? No, this is no trick. We have a proper proof of this. So, tell us the proof. Okay. We can take a look at the proof. Yes. So, instead of going from the LHS to RHS, what I will do is I will simplify from the RHS. Oh, why are you doing that? We can also go from the LHS, but going from the RHS would be easier for you to understand right now. So, sine of A plus B is sine A cos B. So, let me write it in terms of short, sine A cos B, okay, sine A cos B plus cos A sine B, right? Let us write it as this. This is one factor. The other factor is just sine A cos B minus cos A sine B. This is another factor, right? So, can you please observe that this is x plus y, this is x minus y, which will convert to simply x square minus y square. This is sine square A cos square B minus cos square A sine square B. And you can observe that I need a final result in terms of sine and sine. So, let us convert this cos square B and this cos square A in terms of sine square. How do we do that? Sine square A is okay. Cos square B can be done as 1 minus sine square B, right? Since cos square B plus sine square B is equal to 1, we can write cos square B as 1 minus sine square B very easily, right? What else? This is cos square A, which is 1 minus sine square A, and this is sine square B over here, okay? What next? What next? This is sine square A minus sine square A times sine square B minus, what is this? This is sine square B and plus sine square A times sine square B is what I get over here, right? This is what I get. Keeping this in mind, these terms will get cancelled and what I will have is sine square A minus sine square B. As you can observe, this is this result, right? This is one important result, which if you remember this result, you can directly solve this one. But then, do we remember this? No. So, we should have another kind of approach, yes. Let me solve with this approach first. This is sine square A minus sine square B. This will become sine of A plus B. The sum of these two angles would be 6x plus 4x, which is sine 10x, times sine of difference of two angles, sine 6x minus 4x, which is sine 2x. You can see this question becomes oral after this. But then, without using this, we should be able to solve it without using this over here. And how do we do that? That is also possible using simple concepts of transformation. What are the concepts of transformation? Let's take a look at that over here. Sine square 6x minus sine square 4x. It is actually written in the form a plus b, a square minus b square. Can we simplify it as a plus b times a minus b? Yes, we can simplify it in the LHS as this. LHS is sine square 6x minus sine square 4x. Okay. This can be done as sine 6x plus sine 4x times, this is a plus b times a minus b, which will be sine 6x minus sine 4x. This is what you have, right? What next? Next, I would like to apply some concepts of transformation. Concepts of transformation imply that I have formula of sine c plus sine d. What is the formula for sine c plus sine d? This is equal to 2 sine c plus d by 2 sine, 2 sine c plus d by 2 cos c minus d by 2. This is one version, right? This is cos c minus d by 2. That's what we have, right? From the sum or difference, we are trying to convert into a product, because in the RHS we have a product only, right? Okay, sin C plus sin D is 2 sin C plus D by 2 cos of C minus D by 2. And what is sin C minus sin D? Sin C minus sin D will be equal to, you should remember this one as well. This is 2 cos C plus D by 2 sin C minus D by 2. Now these are properly given in the NCERT, right? You should be aware of these, right? These are very useful identities. Conversion of sum or difference in terms of product. Okay, this is something which we have. So let's simplify this further. What do we have over here? Is sin C plus sin D, which can be done as 2 sin C plus D by 2. What will that convert into? C plus D by 2. This will be 6x plus 4x by 2, which is 10x by 2. Sin C plus D by 2. Cos of C minus D by 2. Now what is C minus D? 6x minus 4x, which is 2x by 2. What next? This is sin C minus sin D, another product, and that will be equal to 2 times cos of C plus D by 2. 6x plus 4x is 10x by 2 times, this is 2 cos C plus D by 2, and you have sin of C minus D by 2. C minus D, which is 6x minus 4x, which is 2x by 2. Okay, this is one identity that we have used. What else? This is written as 2 sin 5x cos x into 2, what is this? This is cos 5x. Okay, this is sin x. Okay, but do you observe, where do you want to go? We want to go in this direction, right? Sin 10x is required, sin 2x is required. Now sin 5x and cos 5x can combine together to give you sin 10x using another identity of multiple angles. What is that? Sin 2a is equal to 2 sin a cos a. Or basically this identity in reverse can be used over here. Let's write this 2 sin 5x and cos 5x first. Let's write cos 5x first times 2 sin x, and let's take this cos x at the back. Okay. Now observe this carefully. This is 2 sin 5x cos 5x. 2 sin a cos a, which is sin 2a. This is sin of 2 times 5x, which is 10x, times 2 sin x cos x, which is sin 2x. This is what you have. Sin 10x sin times sin 2x, and yes, this is the right hand side, which can be found using this approach over here. These identities would be required. Yes, these identities from your NCERT directly will be required, and very useful identities, right? Very, very useful identities. Is that all? Yes, that is all in this question.